Good afternoon, everyone. Hello, am I audible?
Yes, ma'am.
Okay. So I think you have done the homework. What was the questions asked in the last lecture? Who is the father of geometry? Have you found the answer? Who is the father of geometry?
Euclid.
Euclidean. Okay. And why it is called the father of geometry? Hmm. Okay, let us start with our introduction of differential geometry. Actually, differential geometry was discovered by the paper differential geometry or the concept of a differential geometry was discovered by Jesper de Monge and C.F. Gauss. Okay, these two mathematicians introduces the concept of a differential geometry in the beginning of 19th century. In the beginning of 19th century. Okay. So actually it is a branch of geometry in which the concept of calculus are applied to the curves, surfaces and geometric entities. Or we can say we can apply the concept of differential calculus, apply the concept of a calculus to the curves, surfaces. As I told you in the initial lectures, I have shown you the syllabus also. First two chapters are depending upon the curves. The second two chapters are depending on the surfaces. And we can say geometric figures or geometric entities or any geometric figures. Okay. So differential geometry is a study of curve and surfaces using the method of differential calculus. Study of curve and surfaces using method of calculus. Using the method of calculus. Okay. Now the main principal object of differential geometry. Actually, in this whole paper of differential geometry, we are only going to study the smooth curves. Yes, anyone can define what is a smooth curve? Or we can say smooth surfaces, because in the next two chapter we are going to see the surfaces. So actually, in the whole syllabus of differential geometry, we are not going to study a peak curve or surfaces, just like a curve like this. This is nothing but your y is equal to mod x. No, these type of surfaces we are not going to study. We are going to study only the smooth curve and smooth surfaces. Okay, have you understood? And main part, the first main part is this one, that we are going to study smooth surfaces and smooth curves. Second one is what we are going to study only local properties. Now one may have a question, what do you mean by local properties? That means before going to this local property, I hope you are knowing how to find out maxima and minima. In that also you have studied local maxima and local minima. Okay, local maxima and global maxima. What do you mean by local maxima and global maxima? Suppose this is say M1 is a maximum, M2 is also maximum of this one, M3. So we can say this are M1, M3, these are local one, but M2 is a global maxima. Correct, no? आहेत का सगळे? Hello?
Yes, ma'am.
So these are what the properties we are going to study, local properties. Now, what do you mean by local properties in differential geometry? That means we are going to find out the tangent, normal, binormal. We will find out how many twists are there in the curve, how many turns are there in the curve. These are all points which are related to local. That means if you are going to study the curve, at every point we can find out what is the speed of a curve, right? The speed of a curve, and then with the help of speed of curve, later on you will come to know how to find out all this tangent, normal, binormal, torsion with the help of a speed. Actually, we have the formulas. These are called Freinet formulas. With the help of a finite formulas, we will find out what is the speed of curve, what is turning of the curve, how many times the curve is twisting, what is rate of twisting, everything, torsion of the curve, will be find out with the help of a Freinet apparatus. Actually, Freinet apparatus are classified into two types. The first one is a unit speed. That means the speed of a curve is assumed to be unit, and the second one is arbitrary speed curve. Okay, now we know that we are going to follow arbitrary speed curve only in our real life, because every time it is not necessary that we will come with the same speed. Unit speed ने चेना रहे अपन. This is not compulsory, because with the things which we are having on the surrounding, due to air, due to rain, due to traffic, all these concepts are going to be imposed on your travel. ओके, जब भी आप ट्रैवल करते हो अपने घर से किसी बाइक पे या किसी पब्लिक ट्रांसपोर्ट से, so you can observe the speed of that public transport or the speed of your own bike will not be constant every time or will not be a unit speed. So that's why the Freinet formulas have been classified into the two types, unit speed and arbitrary speed. Okay, so the speed may be unit speed or arbitrary speed, and here with the help of the speed we can find out what is tangent, normal, binormal on the curve. Okay, at every point we are finding, so that's why we say that it is related to local properties. Yes, everyone agree with this? Whatever the intro I have given you. Okay, starting with the differential geometry was discovered by Gaspard Monge and the C.F. Gauss in the beginning of 19th century. And what it means, it has the study of curve and surfaces with the help of a calculus, the study of curve and surfaces using the method of a calculus. And here in this whole differential geometry, we are only going to study smooth curve. We are not going to study these type of y is equal to mx type of a curve. Sorry, y is equal to mod x type of a curve, because it has some peak. Okay, what do you mean by peak? These type of points are called a peak. And we are going to study the local properties. That is, at every point we will find out the speed, acceleration of the curve. Okay, any doubt for this one? Hello, Ahita.
Yes, ma'am.
Yes, ma'am.
Okay, next one is a Euclidean space. Now everyone know what is a Euclidean space. It is nothing but your R3 space which you have studied up to now. Now can anyone define me what is R3 space, or in another way I can say it is a E3 space. Okay, in the whole paper of a differential geometry I am going to write R3 as a E3 only, because it is introduced by Euclidean, so that's why we'll write down R3 as a E3 only. Okay. Yes, can anyone define what is R3 space? Define करता येते का R3 कैसे define करना रहे? Okay, before that, whether everyone know what is R3 space?
Three-dimensional space.
Okay. Three-dimensional space. So how the coordinates will be there, or how to find a point on the 3D space, and how to define the R3 space?
Three coordinates x, y, z.
Okay, three coordinates or three tuple vector I can say x, y, z. And the condition what we can write x, y, z all are real number. Correct na? Real numbers asतात ना हे?
Yes, ma'am.
Yes, ma'am.
Okay. So instead of defining in the form of x, y, z, we will define in general as p1, p2, p3, where we can say this pi belongs to R. Okay, so actually this 3D space is a geometric tri-parameter model of a physical universe because we are living in the universe. ये भी एक 3D object है ना, because we are हम अपने आप को भी देख सकते हो. We are also 3D, but our image is not a 3D, it is 2D. Observe केलं का कधी? Our image is 3D or
Yes,
2D?
ma'am.
Yes, anyone can answer me whether our image is 3D or 2D.
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 Why it is 2D? Because if you can observe this on a outside of the home also, inside of home also, जब light जाता है तो आप you can imagine your image on the walls of your home, where you can see the image, and that is a 2D plane पे ही दिखता है ना. So we can say that every object in a 3D space or any 3D object, image of any 3D object is a 2D. Okay, so here we have defined E3 space. The 3D space is a geometric tri-parameter model of a physical universe. That means the universe in which we are living, in which all the known parameters exist. A set of all ordered pair of a real numbers. Okay, set of all ordered triplet. Okay, ordered pair of three numbers of a real. Rather, we can say instead of having a numbers, we can say order pair of a three real numbers is called a Euclidean space. Okay, any doubt for the Euclidean space?
No, ma'am.
Okay, now let us discuss how to find out the points on the Euclidean space. That means, suppose we have the 2 points, say P and Q on in our E3 space. Okay, so what will be P? P, suppose it will be with the coordinates say P1, P2, P3, and what will be Q? Q will be with the coordinates say Q1, Q2, and Q3. Okay. So the first point which I have is P is equals to Q if and only if Pi is equals to Qi, right? P and Q both points will be equal only if their all the coordinates are equal. That means this P1 equal to Q1, right? This P1 should be equal to Q1, P2 should be equal to Q2, and P3 should be equal to Q3. Then only we can say that P is equals to Q. Correct? Next one, how to add these two. The 2 points P and Q, whichever we have considered, to add them, what we have to do? We have to add them coordinate wise, right? P1 plus Q1, next is P2 plus Q2, next is P3 plus Q3. Is it correct?
Yes, ma'am.
Okay, let us go for the third one. How to find out the scalar multiplication, that is A into P. That is simply we have to multiply by A to every coordinate, that is A into P1, A into P2, A into P3. On the consideration A should be greater than 0, otherwise all coordinates will be equal to 0, or we can say A to be any scalar. Okay, so these are what the addition, and this is scalar multiplication, and you know that your R3 over R is a vector space. Ahit ka vector space?
Yes, ma'am.
Okay, so with the help of these two, vector addition and scalar multiplication, we have proved that R3 over R is a vector space. R2 over R?
Yes, ma'am.
Yes, ma'am.
Okay, what about R over R? Whether it is also a vector space?
Yes, ma'am.
Yes, ma'am.
What is the basis for this one?
For first one, it is 1. Second one, 1001. Third one, 100, 101, 010.
I think for third one you made some mistake. No, 10000.
10000100001.
Okay, correct. So this is what the basis for our these spaces. Rather, we can say these are standard basis, but we have again ordered basis also. I hope this was a question for oral also or in the seminar. Sir has asked you what is a ordered basis and a standard basis. Order means what? You should maintain the order. अगर आपने कोई basis find out here. Suppose many times in BSc standard you have solved this type of a question. We have been provided with three vectors and you have to verify whether they are basis. कसं verify करतात तुम्ही basis आहे का नाही?
लिनियरली इंडिपेंडेंट असले पाहिजेत आणि त्या वेक्टरला स्पॅन केलं पाहिजे, जनरेट केलं पाहिजे.
So that's why for that you follow this some particular method to find out whether they are bases. But before going to them, first you should check that okay, after finding whether they are bases or not, what you have to do? You have to check their order. Now, what is the standard order? 100, 010, and 001. What do you mean by ordered basis? This one is kept as it is, and there might be a change in these two. And for the second one, these two will be changed, and the third one, these two may be changed. Order means you should maintain that order. Okay. So just go in detail with this type of a question. Whenever some teachers ask you the question, you should go with in detail what do you mean by ordered basis and standard basis. What is the difference between the ordered and the standard basis? Okay, I have simply given you a hint because every time I told you that whenever I am going to explain you anything, it will be remember for you people on your mind that only for 6 to 7 days, and those who are very sharp they can remember up to 1 month. But what about the next? Because unless and until you are going to find out it and you are going to write down on your personal notes, होते हैं ना आपके कुछ खुद के पर्सनल नोट्स जहाँ पे आप कुछ important points लिखते हो. So there you have to write down whatever the research you have followed. Maybe it is called a research because you have searched it on a YouTube or in a particular recommended book why it is called ordered or standard basis. The name itself suggests the meaning ordered basis. कुछ तो order maintain करना है आपको. Now you have to find out which order you have to maintain. Whether this 100 type whatever I have told just now, you have to maintain that order, or you have to find out the basis in such a way that whose first one here it should be one. ऐसा compulsory है क्या? One होना चाहिए. So you have to verify that one. Okay. Now, next one which we are going to see the definition of a tangent vector. The definition of a tangent vector in the E3 space. Okay. Now here onwards we will start our paper of a differential geometry. Now don't confuse with the vector which we have seen in our vector part, जहाँ पे हम किसी भी वेक्टर के लिए ऊपर एक बार कंसिडर कर सकते हैं and it shows that it should have some particular direction. But here it is not compulsory like that. Okay, simply the name is given tangent vector in E3 space. Now I will write down the definition of a tangent vector. A tangent vector VP at a point P in E3 space consists of the two parts. It consists of two parts. What are the two parts? The first one is vector part V and the second one is its point of application, or we can say its initial point. Point of application or initial point. So how the tangent vector VP is defined? VP is with the help of 2 points. The first one we have been provided is a point of application P and it's a vector part, and What do you mean by point of application or the initial point? Yes, can anyone understand the definition from this one, and can you tell me how the tangent vector look like in a E3 space? Yes, what do you mean by tangent vector in E3? Can you understand from this definition? A tangent vector VP at a point P in the E3 consists of two parts. The first one is a vector part, second is a points of application. Okay. So actually I will draw this one. Suppose this is a point of application, say P, and suppose it has some vector part, say V. So here it will be P plus V, and how it is denoted by V suffix to the P. Okay, V suffix to the P. We should always picture a vector Vp as the arrow from P to P plus V. It is nothing, we are going to picture it as a vector from point P to P plus V. The tangent vector to E3 at a point P is a directed line in the direction of a given vector V, which starts at P and terminate at P plus V. It will start at P and it will terminate at a P plus V. Okay, have you understood what is a tangent vector?
Yes, ma'am.
Okay. Any doubt for the tangent vector? Don't assume this vector to be a vector which is there in our vector calculation जहाँ पे हमने v bar ऐसे लिखते हैं ना, and don't consider this tangent to be a tangent which we have studied. A tangent is nothing but the slope of just like in our differential calculus. What is derivative? Okay, suppose I have to find out a derivative f dash. What is f dash? F dash is a slope
Slope of tangent.
slope of a tangent at a point, and the second one is a rate of a change. So don't assume this to be a slope of a tangent, because यहाँ पे slope of tangent कब होगा जब आपके पास कोई suppose function होगा. Suppose we have a some function, then only we can find out slope of a tangent at that point. But यहाँ पे क्या है, ये simply एक vector part है, and with some point of application. It starts at P and ends at a P plus V. Start initial point and terminate point P plus V. P से start हुआ था, that's why P plus this is what a vector part, and hence it is called a P plus V. Okay, and it is denoted by V to the suffix P. Whenever you write the tangent vector, try to write down it is in the form of a small v suffix to the P, because later on we are going to use a capital V where it is for a vector field. Okay, so I will clear this to you people once again. The tangent doesn't mean the slope of a tangent at a point. Slope of tangent कब आएगा जब वो आपके पास कोई function है, and then you can find out the rate of change or slope of tangent or f dash. But यहाँ पे कोई slope of tangent नहीं निकालना है आपको, यहाँ पे कोई function नहीं है. So simply it is a one vector in E3 space. Instead of saying it to be a vector in E3 space, it is defined to be a tangent vector with some point of application P and the vector part V. Okay? Any doubt for this definition of a tangent vector?
No, ma'am.
If not, let us see what are the equal vectors. Okay? Suppose I want to say that the two tangents VP and WQ are, we have suppose two tangents are given to us, say VP and WQ. Okay, the first one I will ask you, when the two tangent vectors are equal, when they will be equal. Equal कर दिया हमारे VP and WQ, just like I have shown you for our vector part. V and Q, the two vectors are equal only if their coordinates are equal. In a very similar way, how you are going to say that the two tangent vector VP and WQ are say equal?
If the initial point is same and vector part is equal.
Okay, initial points are also same and vector part is also Same. That means I can say V is equal to W, that is vector part is same. Second one, I can say the point of application P and Q both are coinciding. Then only we can say that they are equal vector. Now, the second point, that is when we can say they are parallel, parallel tangent vector. Yes, when you are going to say it is a parallel,
If initial point is same.
if initial point is same, then they may not be parallel, no? Initial point same है मतलब P equal to Q. So here will be V and W. दोन्ही parallel आहेत का? Parallel म्हणजे असे असतात
मॅम
ना.
इक्वल आणि कोइन्साइड झाले तर पॅरलल म्हणू शकतो ना आपण.
Equal and coincide. Coincide is different one, no? Coincide में आपका V and W is equal, P and Q are equal. So that is what equal vectors, or we can say coinciding vectors. But I am asking simply about the parallel vectors. Parallel means what? In the last lecture also we have studied this. Parallel means what? We should have a vector part is same. Just like I have shown this for a equation of a line. P naught P is equals to T times V. Why it is called T times V? Because we say that this line, whatever you are going to consider, is in the direction of a vector V. So that's why we can say that the line L1 is parallel to L2 only if they are scalar multiple of one another. So we can say the first thing is vector part is same, but the point of applications are different. Okay, so these are what our tangent vectors. Suppose I have here, say this is with VP and this is with VQ. That means direction is same, but the point of applications are different. Have you understood what is parallel vector?
Yes ma'am.
P and Q different type, point of application different type, but the directions is same. Imagine that you and your friend on two different bikes are going in the same direction. So your point of applications are different, but your vector part is same. That means your directions are same. Okay. Coincide means what? The only one person is traveling. That means point P is equals to Q and the vector part is also same. That is called equal vector, coinciding vectors. Okay. The next thing I will ask you, the third point related to this phase. First one we have seen equal or coinciding, and then parallel, and the next one is intersecting. How the intersecting tangent vector will look like? Intersecting, the name itself suggests the meaning, no? Intersect means what? They are going to intersect at some point, and points of application पे ही intersect करेंगे ना, these type of vector. P is equal to Q, but the vector parts are different, and hence we can say V is not equal to W. That means vector parts are different, but the point of application is same. So hence it is called a intersecting tangent vector. Have you understood the 3 points? First one, we have started with the definition of a tangent vector. Don't confuse it with the tangent which we have seen for a slope of a tangent, or the rate of change which is there in our f dash, or we can say if function f is given, then we can find out it. And also don't confuse this with the vector. That means it should have a direction. ऐसा compulsion नहीं है, direction होना ही चाहिए. You can take any arbitrary direction, but suppose I have given you VP. Okay, so V and P both are given, then everyone will have a same tangent vector. But if suppose I have given you only point of application P, and if I haven't provided you what is a vector part, everyone will select a different vector part. बरोबर ना? Are you getting
Yes
me?
ma'am.
Okay. After this one, we have seen the 3 points: the equal vector, parallel vector, and intersecting. Okay. Equal के लिए दोनों भी equal चाहिए, vector part as well as the point of application. For parallel, we need the vector part should be equal, but the point of applications are different. Imagine you and your friends are going on a bike in the same direction. Intersecting vectors means what? Their point of applications are same, but they are going in a different direction. Suppose you and your brother or sister are leaving from home. Okay, this is what your point where you have your own house. Then from there you are going in a different direction. Suppose your friend, your brother will go to some different college, and you will go to some different college or school. So this is what point of applications are same, but the vector parts are different. Okay, any doubt for this point?
No, ma'am.
Yes, everyone agree with me?
Yes, ma'am.
If you're not having a doubt, let me go for the next point, that is natural coordinates. Actually, we are knowing what are these natural coordinates, but यहाँ पे हमने उसको define किया. Natural coordinates are nothing but your x, y, z. Let x, y, z be a real valued function defined on E3 space. These are real valued function defined on E3 space. So you will find out what are these x, y, z. They are real valued. Means what? We know that their codomain is fixed. Barabar? They are real valued. Means what? Codomain is fixed. Function defined on E3. On E3 means the domain is E3. Correct? So x, y, z are real valued function defined on E3 space. So that's why initially I have written what is Euclidean space. We have defined the Euclidean space as x, y, z, where x, y, z are belonging to R. X, y, z ये real numbers होते हैं, right? So that's why x, y, z these are defined on E3 space. They are real numbers. बरोबर?
Yes, ma'am.
Real valued functions defined on a E3 space. Okay. So this is simply defined with the help of our definition of a E3 space or Euclidean space, or we can say R3 space also. So x, y, z are simply real valued function defined on E3 space. Means what? They are some coordinates. X, y, z का value क्या होगा? Real number ही होगा ना? And they are in E3. E3 में के points है. That's why we can say they are defined on a E3 space, and they have having some real number value. So that's why it is called a real value. Okay. Now suppose I have a point with the say coordinates say P1, P2, P3. Then what will be x of P? What will be x coordinate of P and y coordinate of P and z of P, z coordinate of P? काय असेल?
P1, P2, P3.
Yes, P1, P2 and P3. X point or x coordinate of a point P is P1, and y coordinate of point P is a P2, and z coordinate of a point P is a P3. Is it okay? Have you understood what are natural coordinate? Actually हमें पता ही था. E3 space, while defining a E3 space we have studied. These are nothing but the real valued function. These are real valued function defined on a E3 space. Okay. Any doubt up to this one? Starting from the definition of differential geometry, it was discovered by Gaspard Monge in CF course. It is a study of curve and surfaces with the help of differential calculus, and we are going to study only the smooth surfaces, and then definition of Euclidean space, and then we have found what is vector addition, scalar multiplication, ordered and standard basis. Then we have defined what is a tangent vector and three conditions on this: equal vectors, parallel vector, intersecting vectors, and then natural coordinates. Any doubt for these all points? whichever we have said.
No, ma'am.
No, ma'am.
If you not have a doubt, let us go for the next point, that is tangent space. Okay. Just now we have seen a tangent vector. Now can you imagine what will be tangent space if you are knowing what is a tangent vector?
Collection of tangent vectors.
Okay, collection of tangent vectors, but it has some specific uh, notation which we are using, TP of E3, which means that it has tangent space is related to only one point. All the tangent vector which starts at a point P, we can call this collections to be a tangent space at point P. So that's why it is called a TP of E3. Okay, TP of E3, T is a notation for tangent, P is a notation for the point of application. Why it is called E3? Because P is a point from a E3 space. Suppose this is what our E3 space, and suppose here is a point P. So all the tangent vector which are passing through this point P are called as a they are in the tangent space TP of E3. Okay, we can say all the tangent vector which have same point of application, or we can classify this on the third category. What is a third category? We have seen is a intersecting vector. What is there in the intersecting vector which we have seen here?
Vector part
Intersecting.
is not equal and point of application itself.
Yes, point of applications are same, means what? Here point of application P is fixed out, but vector parts are different. For all the tangent vector which are emerging from P are called a tangent space. उन सबका collection अगर हम ले लेंगे तो उसको tangent space. Now my question is what you, why it is called a space? Because actually it will form a vector space. So instead of saying tangent vector space, it is called a tangent space in the very similar of way of a metric space. Because this particular metric, whatever we are defining on your x cross x, okay, this D is going to satisfy all the conditions of the vector space, hence it is called metric vector space, and instead of calling metric vector space, it is called a metric space. And here also these all type of a tangent vector, whatever the collection we have, okay, let P be the point of application. The set of all tangent vector which starts at a point P are called as a collection of these is called a tangent space, and hence they are going to satisfy all the properties of a vector space. That I will show you how it will satisfy all the properties of vector space, and hence it is called a tangent space. ओके, एनी डाउट फॉर द डेफिनेशन ऑफ अ tangent space? आपको एक पॉइंट ड्रॉ करना है. ओके, from this point you have to find out many number of tangent vector which will start from a point P, and this collection is called a tangent space. And the notation T suffix to the P of a E3 space, that means this point is from E3 space. T is a notation for tangent and is called tangent space since it is satisfying all the properties of the vector space. Okay. Now, the next thing I want to ask you about, everyone knowing how to plot a point on a E3 space? In the starting lectures also I have shown you how to plot a point. येते ना सगळ्यांना how to plot a point on a E3 space? First you have to draw x, y, then y, z, and z x. Then here is your point. Then you have to complete this one. Here is like this. Or you can do it with the cube itself. And this is what you are. ये शॉर्टकट है एक्चुअली, ये एक्चुअली वर्क नहीं करेगा क्योंकि आप जब तक एक्स वाई जेड एक्सेस स्पेसिफाई नहीं करोगे तब तक आपको पॉइंट्स नहीं मिलेंगे ना. दिस इज व्हाट एक्स वाई एंड जेड, and here first you have to find out x y y z and zx, and then combinedly you can find out the point. Okay. Now let us see what we have defined just now, tangent space. So before going to any definition, first we will verify what is a vector addition is defined on this tangent space, because just now we told it is a space, so that's why it should satisfy all the properties of a vector space. Okay, the first one which we are going to see is a vector addition. And this is very easy, which we have seen in the physics somewhere in the 11th or 12th standard. I will draw this image and you will understand which one is this one. VP, this point of application is same, so that's why I'm writing this VP, and suppose this is a WP because vector part is different. Now, how are you going to find out what is V plus W of P? What will be the addition of these two vectors? कुठे असणार आहे addition?
दोन्हीच्या मध्ये.
Okay, where it will lie.
Third side.
Yes. First, you have to complete this parallelogram, and it is called a parallelogram law of a vector addition. Somewhere you have heard in physics, no? You have to complete this. This is WP, and here is also VP, parallel vectors. So point of applications are different, but the vector parts are same. So with the help of that, we are going to complete this parallelogram, and hence it is called a parallelogram of a vector addition. Law of a parallelogram for a vector addition, and here it comes VP plus WP. Correct? And this V plus WP at a point P is nothing but WP plus VP. Okay? So this is what a vector addition which is defined on your tangent space TP of a E3. Now what about the scalar multiplication? Yes, scalar multiplication means A times V at a point P is nothing but A into VP. Simply the everything is depending on this scalar. It may be either 0 or it is less than 0 or greater than 0. Okay. Suppose here is some vector VP, right? All things we are going to imagine on a E3 space. So that's why I have written VP. Then A is a scalar. So if A is 0, this will come to the origin, and if it is less than 0, it will come back, right? It will go in a negative direction, and if it is greater than 0, okay, if it is greater than 0, A is greater than 0 and A is less than 0. So A, if it is greater than 0, it will go in a the direction of VP in a positive direction, and if it is less than 0, it will go in the negative direction. So this will show you the vector addition here with the help of a parallelogram law of a vector addition. And here scalar multiplication means it depends on the value of that scalar you have selected, and hence it is called a scalar multiplication. And you can verify with the help of these two vector addition and scalar multiplication, this TP of E3 is going to satisfy all the properties of a vector space, and hence it is called a tangent vector space. Any doubt for this vector addition, scalar multiplication and TP of E3? Fast होतो का खूप?
No, ma'am.
We read this once again. If you have a doubt, you can ask. Tangent space means what? एक point of application ले लाएं, उसके बाद आपको सभी vectors define करने with same point of application and different vector part. It is just like an intersecting vector which we have studied. The next thing is a vector addition, scalar multiplication, which we have seen in our PSC parallelogram law of a vector addition. Can anyone tell me what will be this one? ये डायगोनल का क्या मीनिंग होगा?
VP minus WP.
Okay, VP minus WP. That because W is in the opposite direction, so hence it is with the negative sign. And here you can see it is in the same direction. यहाँ पे WP is in this direction and here is also in this direction, so that's why it is positive, but the second diagonal will give you the negative one. And you can see that under these two operations, whatever we have defined, it will satisfy all the properties of the vector space, and hence we can say TP of E3 is a tangent space. Okay. Okay, let us stop here because our next thing is a vector field. Because every time if I am going to start with many definition, it will be confusing for you. In every lecture differential geometry, you should know whatever we have seen in the last lecture. Then only you can understand what is there in the next lecture. So that's why be free to ask whatever in the differential geometry. This is what the new paper which you have not studied up to now, because you haven't combined any two paper here in the same paper. So it is a concept of a differential calculus as well as the our geometry. So concept of geometry and differential equation we are going to combine, and we have a new paper. So that's why in every lecture you should be updated. You should go for the definition every time. Then only you can understand the next lecture. Otherwise, some people feel that differential geometry is a very tough subject. Okay, so be positive and then study very well for every paper. And in the next lecture, we will see the definition of the vector field. Okay. Before going to anything else, I want to tell you that in this semester you have the syllabus of Scilab for your practical session. I hope you have studied this one. बघितलं का? Syllabus बघितलात का सगळ्यांनी? In the first
Yes, ma'am.
lecture itself, I have shown you what is a syllabus. In that, I hope you have seen what is a syllabus for your practical sessions. So the syllabus for the practical session is a Scilab, introduction of Scilab, and the next one is a advanced Scilab. Okay, in the first one we have studied a latex, and here we are going to study the Scilab. And even I hope madam has shared you the link of that Scilab. Actually, any app is not available for Scilab for your mobile phone. You can download it on your PC for Scilab का कुछ एक points है 6.61 like this. But for if you want to do it on your mobile phone, you no need to have any app. Directly you can access on the Google itself. Okay, getting me?
Yes, ma'am.
लिंक ओपन करून बघितलं का सगळ्यांनी?
मॅम शेअर नाही केले अजून.
नाही
Ha,
केलं.
yes, ma'am.
Okay, okay. So I will share you later on, and then after this lecture, इसके बाद किसका लेक्चर है? I think ADM is there, no?
Yes, ma'am.
Okay. I will declare after some time whether I will conduct the practical or not. In that session, I will show you what is a link, and from the link itself, you can run the program, you can type the program. No need of having any app for this one. Okay. It is more easier than a latex, and for latex we need an app and all, but here we need a direct access. Only you can go for a Google search and you can search a Scilab console, and then you can get that one, and hence you have to just type on there, and immediately on clicking on a submit button you can get the output of that one. Again, the errors will be there if there is an error in your syntax. And next thing I want to tell you, the Scilab is very useful for the purpose of research, in which suppose you have some different matrices and all. Matrices, if you have studied in your latex में matrix के लिए कुछ conditions है, but here in it is not having some conditions. Matrices, even you can go for some type of calculation. Suppose you provide one table for some image. Suppose it is useful for physics type of a concept. वहाँ पे हम कुछ टेबल तैयार करते हैं ना फिजिक्स के. So if you provide a table, it will give you the image. MATLAB and Scilab, these are very similar for that one. Okay. So Scilab is mostly used for the research purpose, as well as it is used for the writing of any book. If suppose you are writing any book, it is not very easy to write the book on a word, so that's why mostly people refer the latex or the Scilab and MATLAB for typing any book or any journal. Or suppose you are doing a research, then for that you compulsory need Scilab, MATLAB and latex if you are a student of mathematics or physics. Okay. Rather, latex is now made compulsory for every journal, because if you want to submit any paper in the journal, you should submit that paper in the latex format. Okay. So these are the applications. We are simply हम सिर्फ आपको वो लेटेक्स क्या है या साइलैब क्या है उसका इंट्रो दे रहे हैं. ओके, लेटर ऑन यू हैव टू वर्क ऑन दैट. It be in touch of that. Suppose you are writing any seminar or any type of a project you are doing, try to do it on a latex or Scilab. Then only you will be familiar with those app or those software. Because अगर आप पास आउट होने के बाद 2-3 साल के बाद अगर आप वर्कआउट कर रहे हो या रिसर्च कर रहे हो, तब आपको कुछ भी याद नहीं रहेगा. व्हाट इज लेटेक्स एंड व्हाट इज साइलैब, हाउ टू डाउनलोड एंड एवरीथिंग. ओके. So in the next lecture we will start with the vector field, and if I declare a practical, then we will start with the Scilab. Okay. Thank you. You can leave the meeting.